So for number 58, we want to take the sequence here. an is equal to square root of n times sine of pi divided by root n. Okay, and then it's asking us to graph the sequence, which I did using a site called GeoGebra, and then decide whether the sequence is convergent or divergent, and if it is convergent, to guess the value of the limit. So it does appear to be convergent, right, to something about here, and this point here appears to be greater than 3, right? So maybe somewhere here. It does appear to converge. So we're going to guess that an is convergent, and the limit, so we see here that it appears to converge to a number above 3, right? But below 3.2, and because we're dealing with a sinusoidal function and there's pi over there, it does appear that the limit is pi, although we can't know that for sure. So I'm just going to go ahead and guess, and the limit is pi. So I'm going to put a question mark because that's my guess, right? And so once we've guessed it, they want us to prove our guess. So we looked from the graph, we say, okay, it appears to converge somewhere, and that point of convergence is slightly above 3, so we're going to guess pi. And now we have to prove our guess. So what we're going to do is we're going to take the limit as n approaches infinity of our an. So our square root of n times sine of pi over root n. Right? And so if we take this limit over here, this is going to be equal to square root of infinity, well, that's infinity, times sine of pi over square root of n. So it's going to be pi divided by infinity, so that's going to go to 0. So this limit as n approaches infinity is going to be sine of pi divided by infinity is sine of 0, so that is equal to 0, right? And so this is infinity times 0. And now this over here, it's an indeterminate form because we don't know whether the infinity wins or we don't know whether the 0 wins, right? They're total opposites of each other. So it is indeterminate form, and we do have a tool to deal with indeterminate form, which is L'Hopital, but it's not in L'Hopital form yet. So what we have to do is we have to turn this into L'Hopital form. So I'm going to say that this is the same thing as the limit as n approaches infinity of sine of pi divided by root n, and all of this divided by 1 over root n. And so let me clean this up. And so when I did this, I didn't change the meaning, right? Because sine divided by 1 divided by root n is the same thing as multiplying. But now when I take this limit, on the top, I'm still going to have sine of pi divided by infinity, so sine of 0, which is 0. And on the bottom, I'm going to have 1 divided by infinity. So 1 divided by infinity is 0, so that's 0 of 0. And hey, that works with L'Hopital form. And so what we're going to hear, with L'Hopital, we have to differentiate, right? But we can't really differentiate a sequence. We can, however, differentiate a function. And so we're going to estimate this with a function. Because remember that a function, if I were to take the function of sine of pi over x divided by 1, actually I'm not even going to divide. I'm going to just put this one right next to each other. So if I do sine of pi divided by root n times root n, actually not n, it should be x, sorry. X, yeah. Well, what's the difference between this and this? How are they different? Well, they're actually the same thing. The only difference is that with a function, we're going to have all these points defined. So all the points that connect them, right? So we're going to have this continuous thing that goes like this. And that's going to be our function because our function is defined for all real values, whereas the sequence is just the dot and the natural numbers. So we can see here that if we express this as a function, the limit is going to be the same, right? Because it's going to the same place. The function and the sequence, they have the same behavior, except that the sequence is made of dots and the function is continuous. And so what we're going to do here is we're going to find this limit using the function. So we're going to say this is the limit as x approaches infinity. So now we're working with it being continuous of sine of pi over root x over 1 over root x. So as we've seen, this is 0 over 0, right? So what we're going to do here is we're going to use L'Hopital. And for L'Hopital, we have to differentiate the top and the bottom, right? So we're going to say the limit as x approaches infinity. The derivative of the guy on top, that's going to be cosine of pi over root x times the derivative of the inside. So times pi, and the derivative of root x is going to be, let's see, that's x to the negative 1/2, so that's going to be negative 1/2 x to the negative 3/2, right? So this is going to be, I'm going to open parenthesis, negative 1/2 x to the negative 3/2. Okay, so that was the derivative of the top, where we have the derivative of the outside, so the derivative of sine is cosine, times the derivative of the inside, which is just pi, times the derivative of 1 over root x, okay? And then divided this by the derivative of 1 over root x. And this derivative is going to be minus 1/2 times x to the 3/2, and actually should have been negative 3/2 here. Okay, so once we have this, we can go ahead and we can cancel these because these are the same, right? So this is going to be the limit as x approaches infinity of cosine of pi over root x times pi. And so this limit over here, it's going to be cosine of pi divided by infinity. So that is going to be, this is going to be equal to pi divided by infinity, that's 0. So that's cosine of 0 times pi, right? Because pi doesn't depend on x, which is the same thing. Cosine of 0 is 1, which is the same thing as pi. And hey, we have proved here that this limit, so this limit here is pi, and we have proved it using L'Hopital. And so we can see here that we have proved that our guess is correct. So we're just going to go ahead and remove this question mark and just put a tick that our guess is in fact correct, and the sequence does converge to pi.